Welcome. In this and the next two sessions, we'll look at a concept in economics which can be expressed in terms of areas or equivalently in terms of integrals. This is the idea of producers and consumer surplus. To define this, we have to first recall the idea of market equilibrium. We take a product for which we assume we have a fixed demand and supply equations or curves. If we graph them, generally they will intersect at a single point. Remember that demand curve should be falling, the supply curve should be rising. So there will be at most one point where they intersect. We normally expect one point for them to intersect, otherwise there is something weird going on in the market. Now let's assume that the market is at this point of intersection where the demand equals the supply. So in some sense an equilibrium. This is what a physicist would call a stable equilibrium, because think about what happens if there is some slight fluctuation. If the price increases above the equilibrium price, then the demand will fall, the supply will increase, so the supply exceeds the demand, and that means the market forces will drive the price back down. If the price is lower than the equilibrium price, then the demand has increased, supply has fallen, so now demand outstrips the supply. That will drive the price back up, which means that small market fluctuations will eventually stabilize, bring the market back to the equilibrium. Now, even with the market at equilibrium, there would be some consumers who would be willing to buy some of the product at least at a higher price. Because the equilibrium price is lower, the market is keeping price lower than the highest price these consumers are willing to pay, they are saving some money. This is called consumer surplus. On the flip side, there are some producers who would have been willing to accept a lower price than the equilibrium price. So because the equilibrium price is higher, these producers are making some extra money. This is called producer surplus. Of course, there are some consumers who are now out of the market because the price is too high or they are restricting their consumption. Similarly, there are producers who are out of the market because they no longer make enough profit. We are ignoring these. We are looking only at the consumers who would be in the market even at a higher price and producers who would still be in the market even at a lower price. Next, let's look at how we can calculate these quantities. Let me denote the equilibrium quantity by Q naught and the equilibrium price by P naught. Take a price that's above the equilibrium price, say P. Consider the units that would be sold when the price is approximately P. The consumers who would be buying at price P are saving P minus P naught per unit, because equilibrium price is only P naught, so the consumers are paying only P naught instead of P. Let's look at the number of units which would be sold at approximately price P. We get a small quantity dQ, which would be sold at approximately price P. So the amount the consumers save is the amount saved per unit, P minus P naught, times the quantity sold at approximately that price P, namely dQ. So these consumers are saving P minus P naught times dQ. Now we have to total all of this. That would be a Riemann sum for an integral or for an area. Since we are looking at all possible prices above the equilibrium price P naught, it corresponds to all the quantities Q naught which are less than the equilibrium quantity. So Q goes from 0 to Q naught, and so we integrate P minus P naught dQ from 0 to Q naught. This is the consumer surplus. Note that this is also the area between the demand curve and the horizontal line through the equilibrium point. So it's a shaded area in this diagram. So we can also calculate the consumer surplus as that area. The same way, the producer surplus would be the area between the demand curve and this horizontal line through the equilibrium point. The argument runs the same way as before, except now this strip would be below the horizontal line. The area would then be the height from the demand curve to the horizontal line, which is P naught minus the supply function, and integrated again from 0 to the equilibrium quantity. So that gives me this area. Instead of using the integral formulas, we can just think of them as these areas and then write down the integral formulas using a formula for areas. This gives us the formulas which are noted in this slide. If Q naught is the equilibrium quantity and P naught is the equilibrium price, then in the middle column I have formulas for the consumers and producer surplus if the demand and supply equations are given in the form P equals something in Q. If instead we are given the equations in the form Q equals something in P, then we have to look at This picture again, write the area using horizontal strips. For consumer surplus, horizontal strips would run like this. The left boundary is the price axis, which is Q equals 0. The right boundary is the demand curve, Q demand. Price goes from the equilibrium price, the maximum price that anybody is willing to pay. That is the smallest price at which the demand falls to 0. I will denote this by P max. This means that the consumer surplus is given by the integral from P0 to P max of the demand quantity, integrated with respect to P. Same way for producer surplus, the left boundary is the price axis, or Q equals 0. The right boundary is the supply curve, Q supply. P goes from the price at which the supply falls to 0, that is the lowest price at which there is any production at all, up to the equilibrium price. So the producer surplus is the integral from minimum price to the equilibrium price of the supply curve, given in the form Q equals the function of P integrated with respect to P. In the next 2 sessions, we'll look at examples of these calculations.